For this problem, we'll find the standard form of the equation of a conic section. We're told that we have an ellipse and we have information about the foci and the vertices. So we can see that along the x-axis, we have a vertex located at 10, 0. And we also have one located at -10, 0. So remember, whenever you have a vertex, you know that it is exactly a units from the center. So we can see that our center is halfway in between each vertex, or the center will be at 0, 0. And we can also see that A, in this case, is equal to 10. We also know that anytime we have a focus, it's located C units from the center, also along the major axis. So we have -7, 0, and 7, 0. We have a focus located there at each one. Each focus is C units from the center. So we know now that C is equal to 7. Now we're ready to start writing the standard form for this equation. We're going to have x squared over a squared plus y squared over b squared is equal to 1. I know that the a squared goes under the x squared because the x-axis contains the vertices. If the y-axis contained the vertices, I would put the y squared over the a squared. So in this case, I really have x squared over 10 squared plus y squared over, well, we don't have b yet, so we don't know what b squared is yet. So I'll leave that blank for a minute, and I'll set it equal to 1. Well, it's easy enough to find b, because whenever we have an ellipse, the equation that we use is c squared equals a squared minus b squared. So in this case, we have 7 squared equals 10 squared minus b squared. So we have 49 is equal to 100 minus b squared. If we move the b squared over to the left-hand side and the 49 over to the right, we get b squared is equal to 100 minus 49, or 51. So now we can put b squared, which is 51, right where it goes in the formula. And instead of writing it as 10 squared, I can write it as 100. So I'm going to take what I've written right down here in black, and I'll write the final answer up here in red. I'll have x squared over 10 squared, which is 100, plus y squared over 51 is equal to 1. That's the standard form of this ellipse.